this video, we're going to return to triangle group ABC. We're going to use the modeling wizard to design a model, discuss the modeling wizard, do some simulations of triangles from the fitted model, do some comparisons with the ELRF. So the triangle group is ABC. Let's open it. And if you go to the paid losses incremental, let's just make sure it's the right data set. Yeah, it's the one that has a corresponding exposure vector. Click on PTF. And now when you check to see which is the wizard that's active, it should say multiple models, constraints 104. And let's just run the modeling wizard. And we want to check that this is in fact the model that we designed manually in the previous training video. So one way of doing this, instead of running the other model that we call good in the same window, we can create another PTF run. So when you go to load model, click on the downward arrow and choose load model in new window. And if we load model called good, and you now look at the model display, if you look at the title of the model display, it'll say PTF good, that's the name of the model, but number 2, that's your second run of PTF. So now we've got 2 runs, if you like, PTF module open twice, and if we now tile vertically, minimize other types, we can check to see that the model displays are the same, and they are in fact the same. So the wizard did create a model. It created actually a sequence of models that we're going to check in a moment. Now, we no longer need run 2, so if I highlight that, make it active. So PTF number 2 is active. If I click on the X here, top right side, the big X in blue, it'll close that module. Now, which models did the wizard actually create? If you go to load models, you'll see it created an M1, M4, M6. So let me go to a PowerPoint display. Let's see if I can create the pointer. We need in color, red. So the sequence that the wizard went for a number of steps. It created the model M1, then M4. Now M6 is equal to M4. I can't remember the actual argument for doing that. So M6 and M4 is the same. So what it does is it actually designs a model that it saves as M1. It does some further testing and then saves another model, some optimization, does another model and saves it as M4, and then it names M6 equal to M4. Now, most of the time, M1 and M4 will be the same. Let's see what is the case now. So now, the current model is M6. You can see that in any display. If you look at the logbook, LOG, logbook, let's open that. It's the one with the blue, looks like a book, an icon for book. You can see the current saved model is M6, but the wizard saved itself. If I now go to load M1, we know that M4 is the same as M6, so let's load M1. It's in the same window. It's not like if by default, if you just click on the M with the upward arrow here, it's in the same window, so you're not generating another version of PTF. And let's load M1, and if you look at the statistics, the BIC are the same, the trends for memory look the same, so there's no difference. If there's a difference between M1 and M4, then most of the time M4 will be better statistically. The BIC, the Bayes information criterion, provided each one uses the same number of observations, that one will be a better model, as we'll find that out when we look at a case study called C as 5 in a subsequent video. Now, if we look at the model display again, we notice that we've got constraints across the accident years. Okay. Now, constraints are actually set up these bridges, what we've discussed in the previous video, for parameters that are non-contiguous. If you want two parameters that are adjacent to each other to be the same, you just remove the gray from the residual graph and the parameters set to be the same. But what about if you want two parameters to be the same when they're not contiguous? The system will set up, if it does it automatically, these bridges or constraints. So are they useful? Sometimes, especially if, as a result of your business knowledge, that could become quite useful. For instance, along the calendar years, you could be going up at about 10% plus minus 2 for many years. Thereafter, for the next calendar year, the trend might be about 20% as a result of new legislation. And I guess thereafter it might revert to the old trend, which is the 10%. Now this trend estimate might be 11 plus minus 1. This one might be 10.5 plus minus 2. And statistically they're not different. So the system automatically, when it does the optimization, it will set these to the same. You could have the same thing versus accident years. You're going along, all of a sudden this particular year has some freakish weather. As a result of that, lots of accidents. The nature of the size of those claims are different because there are different types of accidents, which means the alpha for that particular accident year is much higher. The next subsequent accident years are at the same level as the previous year here, previous 2 years. So then you would set that level here to be about the same as that level, and that's a much higher level. So it'll be an upward trend and then a downward trend. So that's another place where they'll be useful. Suppose you don't like them, even though this statistical model with the constraints is got better statistical measures in terms of its predictive power than the one without constraints. Suppose you wanted to remove the constraints. Well, one thing you can do is you click with the right button on the model display on the residual graph. You've got your context-sensitive shortcut menu, and you can reinstate only alpha parameters. So you've reinstated them all. And then when you go to the double O and optimize with the downward arrow, just select adjacent parameters only. So let's do that. Okay, you can see no constraints have been set. I mean, we could say if this model is no constraint, but we can compare it to M6. Let's just for the sake of interest. There's M6 or M1, and you can see that the BIC, if we don't have the constraints, is a little bit larger than if we do have the constraints, about a different of 3. And also the AIC is just slightly larger. So statistically, the constraint model is a little bit better, but of course you might be guided just about from business knowledge. You might decide to go with this one, but if business knowledge dictates that those constraints make more sense, then you'll use the one with constraints. If I now go and add another parameter here, say, oops, I clicked with the left. To add a parameter, you really need the L variance, so with the right button, you get an L. Let's reinstate all parameters, so it'll be that one plus all the other variances turned to L. And now, another optimization we could do is what you would call adjacent parameters first. But that's the default. The optimization routine by default, the double O, when you click on it, it does adjacent parameters first, then constraints, then the varying parameters. So adjacent parameters first, let's just check that that is the default. Well, you get the same model. Let's just check in the model display, logbook, and you look at M1, the statistics, minus 233.1 versus minus 233.1. Now the other option is least significant difference first. In other words, it actually chooses between constraints and adjacent parameters and chooses the least significant difference. That usually doesn't work very well, because if you've got data where the alpha is the same for every accident year, but the years jump up and down a bit, if it chooses least significant differences first, which might be constraints, 2 years might be low. 1998 might be low. 1994 might be low. They're not adjacent years, but usually I'm a little bit below the zero line in terms of residuals. It'll probably set up a constraint, which really doesn't make sense. So really the default option is the one you typically use, which is adjacent parameters first. And if you don't like that, you can always go back to and just use adjacent parameters only. Okay. If you look at the residual graph, you can also remove parameters there too. If you also had calendar year constraints, which you don't have here, you could restate all parameters and then click on 00 without having any constraints, adjacent parameters only. Okay, which is a model we have observed before. All right, let's go back to our, say, model, either M1, M4, M6, or good. Let's run good, which is the one we created manually, so they're all the same. Okay, what we're going to do now is actually simulate from this model. We're going to simulate 3 triangles. We're actually arguing that the triangle, the real data, the triangle, we have fitted the distribution to each cell. Maximum line variance versus development here. If you click with the right button here to get the standard deviation, the standard deviation of the normal distributions is 0.0275. Do we have normal distributions? Click on the diagnostic tools. Yeah, we do. So we're actually arguing that the triangle, the real data, comes from the fitted model. We have fitted a normal distribution on a log scale to each cell, and we're saying the observations actually come from those fitted distributions. So now we're going to create 3 triangles, also from the fitted distribution to the real data, and we'll see that it's very difficult to distinguish, almost impossible to distinguish, between the 3 simulated triangles and the real data in terms of their features. So go to option called test, which sits at the top here. It's not a button, test. And then choose simulate triangles for model, not bootstrap triangles, just triangles. Bootstrapping will be handled in a different video. It's a different way of simulating. Simulate triangles for model. Now I'll go to the counter and select 3. Simulate. Counter at the bottom here. With the right button of your mouse, click on the triangle group tab, so you're navigating back to the triangle group, which we called ABC. Now go to Models tab, and take the model good, grab it, make sure that the Models button here is active, grab it, and drop it onto the PLI sim. Then grab it again, and drop it to PLI sim 1. Then grab it again and PLI sim 2. Now, if in the left window pane here, anywhere on the right you click, you'll see all the models and to which data set they apply. Now, my good ones for the simulated triangles are right at the bottom. So I'll highlight each one of the simulated ones. Make sure that's the only ones you've got highlighted. Now, with the right button of your mouse, click on Open. Incidentally, each one of us simulated a different triangle, but from the same model. It's different in the sense that the numbers in the triangle are different, but the structure of the triangle is the same. Same trend structure and same amount of variation around the trend structure. Open the 3. Now tile vertically, with the tile vertically button on the left here, bottom left, and with the downward arrow, minimize other types, and then I've got to tile vertically again because I've got the scroll bar there. And let's look at the trends versus calendar years. And you can see that the simulated data have got very similar calendar year trend estimates as the real data. Now, which is the real data? My real data is the one on the bottom right where it says PLI. The model is called good. The run number is number 1. Then we've got, actually it's really another run, but because it's a different it's another run, but of a different triangle. It's a different data set. That's why it's not called 2. It's still 1 for that particular data set. And this is a simulated triangle, and that's a simulated triangle. So you'll see that your simulated triangles, the trend estimate, will be very close to the real data, which in my case is the bottom right. Now click with the right button of your mouse on the triangle, on the forecast dialog box, and then select all. In other words, we want to do a forecast for each triangle, continuing with the default trend, and OK, 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 OK. Now open the logbook with the right button of your mouse. So we're going to open all the logbooks, the 4 of them. Right button of your mouse on logbook, and now select all. So we'll get 4 logbooks. Grab the first one, push it down a bit, and then scroll to the right. That's the real data in mine. That's the first one. It's 7.12 plus minus 234. Let me check that it's the real data. It is. So for the real data, we should all have the same answer. For the simulated triangles, obviously there will be variations, but statistically the answer should be the same. So this is my first simulated one, and I get 6.9, very close to 7.1, plus minus 210. Let's grab another one. I get 7.2 plus minus 209, so it's on the other side of the mean for the real data. And my third one, I have 7 plus minus 213. So the answers statistically look about the same. Now, is the structure in the data the same? Well, you saw that the model displays. If you click on the right button on the model display icon, this button here, the one with the blue curve with the right button, select all again. Actually, don't have to tile vertically again, they're already tiled vertically. You can see that the trend structures, I don't know why I did that, tile vertically, minimize other types. Okay, very good. Now, what we're going to do now is to each triangle, we're going to estimate the starting model, the SGI model, 1 parameter in each direction. Single gamma with 1 inflation parameter. It's got 1 alpha, 1 gamma, and 1 iota. With the right button of your mouse on model templates, select all, and select SGI, 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 SGI. Then on the residual button, the one with the green diamonds, with the right button of your mouse, select all. Now tile vertically, so the tile vertical button with the downward arrow, minimize other types. And it's pretty hard to tell which is the real data. I guess I can tell because for the real data, there was an outlier. That red label is the fact that that one was really an outlier in the model. Now, otherwise, it's just about impossible to distinguish them. They'll have a similar structure. This data had very little process variability, so mostly trends. If I now close the simulated triangle, so this one is simulated, sim1, so I make that active, and I click on the X, top right-hand side, the big X, close module. Then I'll click on this one, which is also simulated. I'll close its PTF module. Then this one here, which is also simulated, X. And now for the real data, load good again. Load good. And maximize the residual graph. If you now click with the right button anywhere on the right in the residual graph, you can undelete outliers. So that was an outlier. To get rid of it again, you click with the left button to make it black, and you can estimate. What are the other options when you click with the right button? You can That's the shortcut context-sensitive menu. You can show parameter bars, or you can remove them. You can do the same thing from the model display. If you go to the model display, this icon here, right button of your mouse, show parameter bars, you can get rid of them. Okay, let's bring them back in. Show parameter bars. Let's go to the residual graph. Show parameter bars. Okay, now let's go to ELRF with the right button of the mouse. We go to ABC. We go to the paid losses cumulative. We then now click on the ELRF module tab here. So by default, we just calculated the Mack method, the volume weighted averages, the cumulative data normalized by the exposure, and you look at the residuals and you can see a major calendar year shift. So the Mack method is actually overfitted all these calendar years and underfitted these ones, and it hasn't captured the trend structure. So if you forecast, you'll see that you're underfitting 239 versus, look at the forecast table, 194, 190, 194, 239, 264. The fitted values are usually typically lower in the last few calendar years than the actual observed values. Okay, if we go back to the residuals, let's look at that. You might decide that you only want to apply volume weighted averages to the last 3 calendar years. So we can assign zero weight to these years. We can estimate it. You click on E to estimate. You could save that as Mack if you want to. Let's do it. Save Mack 85 plus. To save, you'll have to go to ERN with a downward arrow and click on that button. Save that. You can undo the zero weight. Here, top left-hand corner, there's a little grey rectangle in this corner where the white meets my color there. Incidentally, your color scheme will be better. Not better necessarily, will be different, but you can always go to options and go to graph preferences and change colors and so on. So let's click on this button here. Now estimate. We've undone the black. Now, I want you to tile vertically, minimize regression tables. So you just get the residual graph. With the right button of your mouse, click on the PTF module right button. Select ABC, PLI, PTF. The model good has been changed. Let's just check that it has been. Has it been changed? Open the residuals. No, it's still good. Model display. We must have played around with it a bit and done certain things to it. The one we loaded. Then tile vertically. Just tile vertically. We've lost the residuals for the PTF, so click on the model display again. Click on the residual button. Tile vertically again. So on my left side, I've got the residual graph for our PDF model called good. But to make sure it's good, let's just load it again. Load, model, and double click on good. On the right side, I've got the Mack residuals, and I can't capture the calendar year trends. There's just no way of doing that. If on the left side in the PTF model, identified model, I can remove all the parameters except for one. This little box here in the bottom left, little grey box. Then set the trend to 0, so you click on the number, the little box above the number 78 to get a red line, meaning let's set the trend to 0 in the method, but I haven't estimated it yet. So let's click on E to estimate. So now the method has a 0 trend along the calendar years, and the residuals represent the trends in the data minus the trend in the method, which is 0. So it's really the trends in the data. You can see a similar shape as you would see from the Mack method. But in the PTF modeling framework, if I highlight that again, I can estimate the trends structure by either loading good again, or I can go, an alternative way of doing that is you go to the logbook, log. Oh, I've got to make it bigger. It's become pretty small. And I can run the previous model by just double-clicking on that line in the logbook. Model good. Close. Okay. But with ratios, what can I do with ratios? I don't have any parameters. So now if you look at the residuals of the Mack method, I don't have any parameters in that calendar year direction at all. So it's like my hands are tied behind my back. All I know is the method has estimated some trend in the data. It's overfitted all these calendar years, and it underestimated this more recent calendar year trend. What I could do is I could go to Model Templates in ELRF, string button here on the left. I can select trend and ratio. Okay. And then I can optimize twice, and that's the best I can do. So the method we have now, which is a combination of ratios, trends, and so on, if you go to the regression table, ERM, R as in Robert, regression table, you can see it looks a bit like a, I don't know, I guess like my dog's breakfast. I don't know anything about what's going on in the data. If you go back to the residuals, you know the method we've just used estimates an average trend, but that average trend is larger than the trend in the early calendar years and is smaller than the trend in the later calendar years because the residuals represent trend in data minus trend estimated by the method. Let's close the ELRF module. So you go to X with the downward arrow and close. We still want to keep PTF open. X here to the left of your screen. It's just under the calculator or the topic help handbook. With the downward arrow, close all ELRF modules. So we're back into PTF. If you're not back into PTF, click with the right button on the PTF tab and select it. Go to the model display. Let's suppose we want to do some forecasting. Okay. Forecast. But we don't want to really continue with this default, the default trend. When you go to forecast dialog box again, and you go to future parameters, and you highlight change iota and standard error. Well, obviously it's all the same for all the calendar years. But let's suppose now you want to do a couple of things. You go to periods, and you want to, because this is workers' comp, you might decide that you want to forecast a development year, say 30. You want to do that. Okay? You then go to future parameters, and you found out that the 16.91% trend, let's cancel this for a second. The 16.91% trend is really due to new legislation. So let's go to the residuals again, tile vertically, minimize regression tables. Whoops, what happened to the model display? Oh no, because it's been maximized. So I'm going to move it down a bit, open the model display, reduce it in size, and then tile vertically. So we have a model display and the residual graph, side by side. I hope I'm not going too fast. If I am going too fast, there's no reason why you can't pause the video, or after working for the video once, you might want to work for it another time again, and it'll be good practice. Let's actually estimate the trend between 86 and 87. And you can see that from 85 to 86, the trend statistically is larger than the trend, the estimate is larger than the trend from 86 to 87, so it seems to have come down a bit. But the pink line says there's not a statistical, the difference is not statistically significant. So if you click on O, we're back to model good. Incidentally, some of you might have observed when you look at the residuals, it seems like there's a trend from 80 to 83 and then a downward trend. Well, let's just test that. So add a parameter from 80 to 81 and one from 83 to 84 on the x-axis of the residual graph on the boxes between the years. Estimate and click on double O, and you'll find there's nothing there. So, okay, let's go back to this idea that the 16.91% is new legislation. You believe that from now on the trend will revert to the 6.52%. So, but you're going to be a little bit conservative because when you look at the model display, you notice that versus development years, the peak is at development year 1. If we just do a default forecast, click on forecast table, and you actually forecast, you find out that when you look at the forecast summary now, FS, forecast, that's the forecast dialog box, then the FS icon comes up, and you look at it by calendar years, most of the money you're paying really in the next year. So what you're going to do is you are going to be conservative, and the scenario we're going to look at for forecast, before we do that, let's click on the model display. So I've got the model display versus calendar years, and let's reduce it in size. So I'm going to move it here. Okay, I'm now going to open the forecast dialog box, and I'm going to go to future parameters. Now, so we're going to set the development pattern to say 30 for workers' comp. And when we go to future parameters, we're going to assume that 16.9, we're going to be conservative, actually lasts for 1 year. And thereafter, it reverts to, even though we believe that the 16.91% will revert immediately to 6.52, we're going to be conservative for 1 year because a lot of the payments we're actually making out of the total reserve in the next calendar year, and we don't want to be wrong on the next calendar year. So you click on 88 to 89 to add another parameter, and we make that parameter 0.0652, and the standard deviation 0.0045. So I'll wait for you while you do that. And let's click on OK. Let's now save that as default save. You can save as anything you like. 1 year. Then all trend. So let's save that. Go to, now click on OK. So if you look at the forecast summary by calendar year, you'll see a lot of money next year and so on. If you look at the forecast table, F for forecast table, and you look at your liability stream, you're paying at 1.2 million, 1.5 million, 1.9 million. Now we're forecasting a 1.8, but it doesn't include development year 0, which will be close to 500,000. So that would bring it down to about about 2.3 something, around 2.3 million. If we had a forecast in that particular cell. Remember, the next calendar year that does not include a forecast for development year 0, but the total the total paid in calendar year 87 does include development year 0. Okay, so let's look at the forecast summary, and that's the sort of reserves by calendar year. You've got your standard deviations, CV of outstanding, cumulative payment as a percentage of total. I mean, by the time you reach 1993, you've made 84% of your payments. Now, I want to run a different scenario, and let's now load the model in a new window. Load model in new window, and it's model called good, or M1, M4, M6, it doesn't matter. Now, when you go to forecast, you can load the same scenario, also going to development year 30, but now assumes that it reverts to the old trend of 6.51 centimeters. So you go to change the iota and standard error, and I think the way to do that, I think one way to do that to be safe is I copy this line here, copy to the first line, and then I paste on the right here. Okay, so then we just have the old trend reverting immediately. We don't need that line here, it's superfluous, so we can remove it on the graph. And then, okay, then insert, you know how to load a model in a new window. You go to the M, and then with this downward arrow here, you select load model in new window. So did I save this? Let's save it. So basically it's old trend. Okay. Now let's compare the two forecasts. So with the right button on the forecast, right button of your mouse on the forecast button, forecast icon, all. Now tile vertically, minimize other types. Let's call here bottom left. I'm just going to tile vertically again. So you can see that once you include that 16.91% for at least 1 year, it goes up to 1.7, but the 1.32 is already at a higher level, so the 1.32 and the 890 are already higher than the 1.174, the 802. Now, the difference between these two forecasts, one can use to release capitalist profit if the more conservative assumption that we made about the 16% trend continuing for the next year doesn't really play out. What do I mean by that? Let's go back and look at the forecast summaries. So with the right button of your mouse on the forecast summaries and tile that vertically versus minimize other types and look at each one, calendar year summaries. What's the difference in the forecasts? 6.4 million versus 5.82 million. So it's a big difference, about 500 million. I mean, we went out to 2017, and the first calendar year that we forecast for is 99 and 98. So that's quite a big difference. So what we're really saying here is that we have one assumption is that the 16.9% continues for 1 year and then reverts to the old trend. That's scenario one, which is pretty conservative. Suppose you go with that scenario. But then it turns out that the old trend kicks in immediately. In other words, the 16.9% doesn't. So then you're back there. Actually, I'm not sure that's the best way to do it. The better way to do it actually would be that if it continues, if just one minute, let me just think for a second. So the less conservative scenario is it reverts immediately to the old trend. And the difference between these two forecasts, which you can see is quite large because that 16.9% is going to make a big difference, is the kind of capital you can release as profit next year if it turns out that when you do the updating, which we'll do in a second, the new trend actually, the trend actually reverts to the old trend that you had many years ago. Okay, so you can use the system. I mean, you can work out really now what kind of capital you might release with profit if the if this very conservative scenario doesn't really play out. Now, okay, now both these scenarios have been saved. If I go to X and go down and with the X downward arrow here on the left under the book, help book, or the calculator, let's get rid of the calculator, X with the downward, close all regression tables. Sorry for that. Do you want to save? Well, we saved the forecast summaries, we saved the model. No. If you Go back to the triangle group. This is one way of doing it, clicking on the triangle group view, or another one which is definite and certain is you click on the triangle group tab, ABC. If you go to forecasts for PLI, you can see that you saved your forecast scenarios. Now, if we go back to models and run the model again, good, and load the forecast scenario, which we called, let's do the conservative one. I mean, we call it conservative, and that one was reasonable. Okay, so let's up the conservative. We actually forecasted development year 30. But it's pretty well known with workers' comp, as you go further out to the tail, to further development years, what actually happens is the decay becomes less and less strong. Okay, so let's change our assumptions. Go to future parameters, and let's change our assumptions about changing gamma. So what we could do, and a lot of it is just based on judgment or what you might have seen in other portfolios. So when it goes from, say, 15 to 16, I might make the trend now minus 20%. You might also be guided by what's in the case reserve estimates. Now, minus 0.2. And then, say, from 24 onwards or 23 onwards, let's make it minus 0. Whoops, wrong one. Here, minus 0.1. Okay, it's the kind of thing that happens with workers' comp. So you go to OK, and you could save that. Maybe that one, lighter tail. Okay, save. Okay. Okay, so get out of the triangle group. You've closed it. We're back into the database. Highlight ABC. Expand it. So we're going to add another diagonal. It'll be called ABC1. We're adding one more diagonal. Okay. So this is updating, adding another diagonal. Now highlight both with the right button of your mouse. Open both. Now tile vertically, minimize database view. So you only see the two triangle groups. Run model good for each. Good. On the other side, good. Tile vertically. Minimize regression tables. Well, let's look at the residuals versus calendar year. Let's look at the model display. Well, the model displays will be identical because the next calendar year we added doesn't have any data. Okay? If you want to forecast the expanded triangle forecast, you can actually load a forecast scenario. Okay? You can do all that. So updating and forecast tracking is pretty easy. If it actually continued with a trend of 16.91%, the residuals for the next calendar year would be sitting around the zero line. If the trend dropped, they'll be below the zero line. So updating, monitoring, forecast tracking, making sure that your estimates of prior year ultimates are consistent on updating. We'll deal with that in the next video. It's all pretty straightforward. Okay, thank you for that. Close all triangle groups. X for the downwards arrow.